This is Physics 2122, General Physics 2. General Physics 2 for STEM students. Now, our topic this afternoon is electric field and electric flux. Electric field taken from week 1 and electric flux from week 2. Okay, our objectives are, at the end of the presentation, the student will be able to A. Define and describe an electric field. B. Apply the concept of electric field in simple problem solving. And C. Define and describe the concept of electric flux. Letter D. Calculate the electric flux for a given situation. Okay, so what is an electric field? Based on our last meeting's discussion about electric charge, if you understand the concept of electric charge, then madali na lang yung pag-understand natin dito sa electric field. Okay, so electric field is a region in space in which a charge would be acted upon by an electric force. Okay, so imagine a single charge. Okay, a single charge, say positive Q, would set up an electric field in the surrounding region. Yeah. Okay. Now, if we take the positive charge away from that point, transfer lang natin yan dito. So, transfer natin dito. Okay. How will we know na there is or present yung electric field in this area? Okay. Now, we have what we call test charge or Q prime. Test. Pang-test lang natin ito kung meron bang electric field sa region. So, if we bring in Q prime at any point in the electric field or in the region, so kung maka-experience itong Q prime ng force, ibig sabihin, merong electric field dito. That is, if maka-experience yung test charge ng force. Okay, that is similar to kung meron tayong magnet. So, sa magnet, merong magnetic field. Paano natin malalaman na merong magnetic field? Dapat meron tayong iron material. Ano ang purpose ng iron material? To test. No? So, kung may attraction doon, ibig sabihin, there is magnetic field. No? So, ganun din yung concept ng electric field. Now, electric field may be produced by single or several charges. It may be uniform or vary in magnitude and or direction from place to place. Mathematically, electric field is equal to force divided by charge, or F over Q. And since sa topic ng electric charge, may formula ng force doon. That force is equal to K, Q1. So let us write Q instead of Q1 and Q prime instead of Q2. And all over square ng distance. Okay. So let us substitute that in the force dito. That gives us ito na portion na to. This is force. And then divided by Q prime. Okay? So makancel ito, giving us KQ divided by square of distance. So electric field again is equal to F over Q prime equal to KQ divided by R squared. So in K, constant ito from Coulomb's law. That's equivalent to 9 times 10 to the power of 9 newtons times square meter divided by Coulomb squared. Q must be expressed in terms of coulomb. Now, may mga problems na naka-state like 1 microcoulomb, 1 nanocoulomb, or something expressed in nanocoulomb, say picocoulomb, no? So, mga prefixes lang yan, no? Prefix, no? So, micro is 1 to the power of negative 10 to negative 6 coulomb. So, tanggal lang itong micro na change ng 1 to 10 to negative 6. And nano is 1 times 10 to negative 9 coulomb. Pico is 1 times 10 to negative 12 coulomb. Okay. So, yung distance naman, kung naka-express ito in cm or in mm, so kung naka-express siya ng other units like feet or naka-inches, naka-cm, naka-mm, you need to convert that to m. Bakit naman kailangan, ma'am? Okay. Kasi yung unit ng constant expressed in newtons, meter, and coulomb. No? Para madali lang yung cancel. Or, if you want, ito ang i-change ninyo, mas mahirapan kayo, no? So, do not alter the unit ng constant. Dito tayo sa given mag-convert. Okay. So, electric field is a vector quantity. You need to consider the magnitude and direction in finding resultant electric field. The unit of electric field is newtons per coulomb, N over C. That is equivalent to volts per meter. Equivalent to volts per meter ang newtons per coulomb. Okay. So the advantage of knowing electric field at some point is that we can at once establish the force on any charge Q placed there. So recall that electric field is force over charge. No? Okay. In finding the force, you have to multiply electric field by charge. Okay. Now, what about the direction of electric field? If we are given a positive charge, the direction of the electric field is same sa direction ng electric force. Pag negative ang test charge, the direction of electric field is opposite to the direction of force. Now, let us apply the formula of electric field in a simple problem. Okay, this problem states that what is the electric field? 30 cm from the charge Q equal to 4 mc. Balik. So, what is the electric field? So, yan ang unknown. Sulat ninyo yan dito sa find, no? And then, 30 cm is our R. Convert automatically to meter. So 30 cm divided by 100 cm is equivalent to 0.3 m. And then next, the charge is 4 nc. Ano yung n kanina? Nano. So 4 times 10 to negative 9 coulomb. Ayan. So and then, recall the formula of electric field. Kasi electric field ang hinahanap dito. F over Q. Do we have F? Wala. Okay. Dito tayo kasi distance and charge ang given. So, you copy that formula, you place it under solution, no, part, and then substitute all values. Quantities given. So, since K, this is constant, no, from Coulomb's law. So, that is equivalent to 9 times 10 to the power of 9 newtons times square meter divided by Coulomb square. And then multiply by the magnitude of the charge 4 times 10 to negative 9 coulomb. Divide overall, divide yan by square of 0.30. So if you have scientific calculator with you, i-check ninyo kung ano ang value ng electric field. Okay, so the value of electric field is 400 newtons per coulomb. Ibig sabihin na the value of electric field 30 cm from the source or from 4NC is 400 newtons per coulomb. That's the value. Another example, we have the second problem. The electric field of a certain neon sign is 5,000 volts per meter. Electric field. So, given yan. No? Next, what is the force? So, unknown ang force. Yan ang unknown. On the neon ion of mass, this is M, and a charge of positive E. Mass and charge. Now, in finding force, this is the derived formula. Okay. So, next problem is, kasi given ang electric field, ano ang value ng Q? Okay. In last meeting's discussion, I gave the constants of single proton and single electron. So, nabigay ko doon yung charge ng proton at saka electron, as well as mass of proton and electrons. Now, since this is plus E, so this is charge of proton, equivalent to 1.6 times 10 to the negative 19 coulomb. So, simply multiply that by electric field, and in doing so, makancel ito, giving us unit of Newton in force. Unit of force in newtons. Okay. Next, so what is the acceleration of the ion? Now, when we think of acceleration, ma-recall natin yung acceleration formula ng General Physics 1, that is change in velocity, or V2 minus V1, all over change in time, or delta T. Delta V over delta T is acceleration. Now, since we don't have V and T in the problem, then think of what other formula can solve for acceleration. Now, walang iba kundi yung second law of motion by Newton, or Newton's second law of motion. So, F is equal to M times A, or acceleration is directly proportional to force and inversely proportional to mass. Second law of Newton. Now, next is to plug in given. So, we are given force. Solve force now sa A. Yan ang gamitin dito. At saka yung mass na 3 to negative 6. Mass ng neon ion. Again, use your calculator to solve for acceleration. The value therefore is 2.4 times 10 to the power of 10 meters per square second, or per second square. Okay, let us continue. Field lines. So, lines of force are means of describing a force field, such as an electric field. So, this use an imaginary lines to indicate direction and magnitude of the field. Okay, so a single positive charge would have this field lines, radial, no? Take note that the direction of electric field is away from positive charge and to the negative charge. The direction of an electric field lines of force, or lines of force at any point, is the direction in which a positive charge would move if placed there. So lines of force are drawn close together, the field is strong, and far apart, the field is weak. Now, you look at the third figure. So, sa point na ito, the field, electric field, is strong. Whereas dito, electric field is weak. Sorry. dito. Weak. Na? Why? Because there are many field lines concentrated in the given area. Whereas dito, na, so by yung mga distances, medyo layo-layo na yung isang field line to the other. No? Nakapa-weak yan sa electric field. Now, sa next na figure dito, we are given two plates, one positive, the other one negative, and take note that the direction of electric field is away from positive charge to or going to negative charge. Okay, so in this case, electric field is constant at any point dito between two plates. Okay, field lines was introduced by Michael Faraday. Field lines can begin or end a region of space only when there is charge in that region. Okay, we have these important general properties in considering electric field. Okay, A, field lines originate from positive charge and would end at negative charge. If there is a single charge, they may start or end at infinity. B, in a charge-free region, electric field lines can be taken to be continuous curves without breaks. Next, two field lines can never cross each other. If they did, the field at that point of intersection will not have a unique direction, which is absurd. Letter D, electrostatic field lines do not form any closed loop. So yun ang mga important points in considering electric field or field lines. Now let us compare electric field from magnetic field. No? So electric field are produced by two kinds of charges, positive and negative, while magnetic field are associated with two magnetic poles, north and south, although they are also produced by charges but moving charges. Okay, in electric fields, like charges repel and like charges attract. In magnetic field, like poles repel, unlike poles attract. In electric field, points in the direction of a force experienced by a positive charge, while in magnetic field, experienced by a north pole. In electric field, positive and negative charges can exist separately, meaning a single positive or a single negative, no, alone, no. But in magnetic field, north and south poles always come together. Wala pa tayong tinatawag na monopole or single pole. It would be north-south poles when we talk about magnet. So electric field have definite starting point and ending points. But magnetic field are continuous loops. Okay, so next, let us compare electric field to gravity field. So pareho, obey inverse square laws. Pareho act between two bodies without any means of contact, but they differ. Sa electric field, this would act on charge, while force acts on mass. The gravitational field acts on mass. And electric field, the force can be, dito yan, attractive or repulsive. Gravitational field, force are only attractive. And electric field is much stronger than gravitational field. Okay, so let us consider the figure. We are given a single positive charge, and this positive charge created field lines, no? May field lines, no? Now, consider na merong dalawang rectangular area elements dito sa region A and B. So even though these elements have the same area. Itong rectangle dito sa A at saka sa B, magkaparehong area. The number of electric field lines crossing the element in region A is more than that crossing the element in region B. That is, maraming field lines dito na makakross sa virtual surface rectangle ng A. Whereas, konti lang yung field lines na makapass or maka-cross ng virtual rectangle B. Now, so they differ in number of field lines. Kasi at this point, strong ang field, weak ang field. So, weak ang field ng B compared sa A. No? So therefore, the electric flux in region A, so electric flux dito na portion sa A, is more than that in region B. So greater ang electric flux in region A than B. The electric field strength for a point charge decreases as the distance increases. So, lesser na yung effect ng electric field in this point compared sa point A. Lesser na ang strength ng electric field sa point B compared sa point A. So then for point charge, electric flux also decreases as the distance increases. So electric flux nagapa-decrease while increase ang distance from the charge. Okay, so let us define what is an electric flux. So electric flux is the rate of flow of the electric field through a given area. And this is proportional to the number of electric field lines going through a virtual surface. Mathematically, electric flux, this is PHI, Greek letter PHI. Flux is equal to electric field times area. Electric field times area, tapos cosine of angle if there is angle between the line perpendicular na surface to the direction of electric field. Okay. Now, flux varies by how the boundary faces the direction of flow. We look at our diagram. Pag nakaslant, no? Naka-incline, lesser ang number of field lines. At pag naka-perpendicular yung surface ng field lines, maraming field lines na makapass through a given area. And then, the smaller the area, lesser din yung number of field lines maka-cross. So, with larger area, more field lines can cross it. No? Okay, flux is proportional to the density of flow. Now, let us apply that in the worded problem. Okay, so the problem states that a uniform electric field with magnitude 8,000 newtons per coulomb passing through a flat square area equal to 10 square meters. Determine the electric flux. Okay, so analyze again the problem. Tapos summarize kung anong given, at saka unknown ng problem. So we have electric field, area, and find the flux. Ito yung unknown. Okay? So then, recall the formula of electric flux. Recall ninyo yung formula electric flux. Dito sa solution, iyan. And then, what is angle? Okay. So ito yung figure. We have a line perpendicular ng surface, naka 90 degrees yan. Ano daw ang angle doon sa field lines? No? So, since this is parallel, so our angle therefore is equal to 0. Okay. So that's why we have here 0. So cosine of 0 multiplied by 10 multiplied by 8,000 is 80,000. Cosine of 0 is 1. So 8,000 times 10 is 80,000. So the unit of electric flux is Newton times square meter over coulomb. Okay. So continue tayo. Gauss law. This is an alternative formulation of the relation between charge and electric field, also known as Gauss-Flux theorem. This is a law relating the distribution of electric charge, the resulting electric field. It was formulated by Carl Friedrich Gauss, logically equivalent to Coulomb's law, and is one of the four Maxwell's equations, which form the basis of classical electrodynamics. It states that the net outward normal electric flux through any closed surface is proportional to the total electric charge enclosed within that closed surface. Okay, so let us analyze how to find electric flux in different situations or conditions. Okay. In the first figure, you look at the direction of electric field. This is parallel to the virtual surface. So ang line perpendicular is ito. So naka 90 degrees. So from the electric flux formula, equal to electric field times area multiplied by cosine of an angle. So the angle between the line perpendicular surface to the direction of electric field is 90. So what is cosine of 90 degrees? Cosine of 90 degrees is 0. So once you multiply 0 to any value ng electric field and area, magiging 0 ang electric flux. Next figure. Now we have the electric field direction at an angle to the line perpendicular ng surface. So if there is angle, kung naka-incline ang electric field on, so i-multiply lang ninyo cosine of ng angle and product ng electric field and area. Okay, so the third figure, we have a line perpendicular na surface. This is 90 degrees sa surface. What is the angle between the line, ito na line, and the direction of electric field? So since parallel, the angle is 0. Okay. So cosine of 0 is 1. That is why to find for electric flux, this is simply electric field times area. Okay. Next figure. Ito, fourth and fifth magkapareho. So to compute for the electric flux, the total is 0. Bakit 0? Because the flux is negative in one side. The flux is positive on the other side. When you add that, the total is 0. Okay, so in 9 minutes, maputol tayo. Kung hindi pa tayo matapos, mag-log in na kayo. Okay. May summarized form dito. All you have to do is to analyze kung anong klaseng conductor, no? So, kung location of excess charge in a conductor, electric field is 0. Therefore, electric flux is 0, no? Next, field of a charge conducting sphere. Field of a charge conducting sphere. The electric flux, therefore, is equal to charge divided by epsilon naught with constant value yan. Okay. Field of a line charge. So electric charge is distributed uniformly along a long, thin wire. Charge per unit length. So lambda is charge Q over L. So, to find electric field, ito. Or, pwede na lambda ang hanapin. Pwede ito, pwedeng R. No? 2, pi, and epsilon sub O are all constants. For field of an infinite plane sheet of charge. So, use the formula. Okay? So, where sigma is charge divided by area. Charge per unit area is sigma. Okay, so let us apply that to a simple problem. The problem states that a long straight wire has a charge per unit length of 3 times 10 to negative 12 coulomb per meter. So analyze long straight wire. Ano yan? Dito yan sa formula 3. Field of a line charge. So, ang gamitin ng formula ito. No? Okay. So, formula 3, no? With the value 3 to the power of negative 12. Sulat yan dito. Lambda yan siya. This is negative 12. No? So, at what distance? At what distances are unknown? When the electric field is 0.6 newtons per coulomb. Simply find R. Now, using the formula, R is lambda divided by electric field divided by 2 divided by pi divided by epsilon naught. So next is to plug in the given quantities. Lambda is 3 to negative 12. Electric field is 0.6 and all other constants. Next, if you have a calculator now, then you check the answer. The answer must be 0.9 meter. Okay. Now, how come, ma'am, how come naging meter ang unit? Okay. So, balik tayo sa unit ng lambda. Lambda is expressed in terms of coulombs per meter. And then, divide newtons per coulomb, or is reciprocal? Coulomb per newton. The unit constants ito, unit ng permittivity constant, reciprocal, Newton, dot m squared divided by coulomb squared. Okay, so ito makancel itong c times c is c squared. Makancel ang n at saka n. 1m with 1m. So that is why m na lang ang unit ng distance. Another example. What is the charge per unit area? Charge per unit area. So this is sigma. No? One infinite plane sheet of charge. Naka-indicate dyan infinite plane sheet of charge. Nasa formula 4 tayo. Itong formula 4. Okay. It has a magnitude of 3 NC, magnetic field. So, sulat ninyo yung value ng magnetic field. Sigma is unknown, no? And then, we knew na our conductor is infinite plane sheet of charge. So, ito yung formula doon sa 4. And to find sigma is simply multiply electric field by 2 and epsilon. No? So, galing yan sa electric field is equal to charge per area to epsilon naught. So to find sigma is to multiply electric field by 2 and by epsilon sample. Use your calculator, and then the answer is 5.31 times 10 to the negative 11 coulomb over meter squared. Now, what happened to our unit? We have N over C multiplied by reciprocal unit ng constant, Newton, that M squared divided by coulomb squared. Ay, kasi times lang ito. Walang reciprocal pala. So this is, say, times coulomb C squared divided by N M squared. So makancel yung 1C with 1C. May naiwang isa. Ito yan. Cancel yung N at saka N. M na lang naiwan. This is M squared therefore. Okay, so that's it. Okay, so for our lesson summary, electric field is a region of space in which a charge would be acted upon by an electric force. May be produced by a single or several charges, uniform or constant, depende sa place, no? Okay, electric field is force over Q equal to KQ over R squared. This is a vector quantity. The electric field unit is newtons per coulomb, or its equivalent volts per meter. The lines of force are means of describing a force field. So positively charged away from the positive charge and direction to the negative charge, pag negative. Formula ng electric flux. This is the rate of flow of electric field, no? Electric field times area is electric flux. Okay, so that's all for today.